In this video, the learner will use the converse of the Pythagorean theorem to classify triangles. So first, let's recall what the Pythagorean theorem says. If a right triangle is right, then a squared plus b squared is equal to c squared. A and b are the legs of that right triangle, and the hypotenuse is our c value. So a squared plus b squared is going to be equal to c squared. So for this triangle here, I'm going to use a squared plus b squared equals c squared. A and b are going to be the 6 and 15, and it actually doesn't matter which leg is a or b, as long as those are the legs. So 6 squared plus 15 squared equals x squared. 6 squared is 36 plus 15 squared, which is 225, gives us 261 equals x squared. And the square root of 261 will be our answer. For another triangle, this time we're actually missing one of the legs. So again, we're going to use Pythagorean theorem, a squared plus b squared equals c squared, because we know already that the triangle is a right triangle. So now we have x squared plus 9 squared equals 11 squared. So x squared plus 81 equals 121. X squared is then going to equal 40 when we subtract 81 from both sides. And x is the square root of 40, or 2 square roots of 10 once that is simplified. Now we can also use the converse of the Pythagorean theorem, which states if a squared plus b squared equals c squared, then a triangle is right. So if we know that those values work in a squared plus b squared is equal to c squared, then we know that we have a right triangle. But what happens if it's not equal? We can actually use this converse and modify it to actually classify triangles. So what happens when we have a right triangle? Well, the relationship of the sides follows Pythagorean theorem. If a squared plus b squared is equal to c squared, then the triangle is a right triangle. Well, what happens when we have an obtuse triangle? If c squared is bigger than a squared plus b squared, then the triangle is obtuse. So if we calculate the c squared value, and it is larger than a squared plus b squared, we have an obtuse triangle. It's also worth noting that c is always the longest side. When we have an acute triangle, if c squared is smaller than a squared plus b squared, then ABC is an acute triangle. So when c squared is less than a squared plus b squared, we have an acute triangle. We're actually going to use these relationships to classify certain triangles. In A and B here, I'm given 3 numbers. I first need to determine whether these values actually make a triangle at all. And then once I know they make a triangle, then I can classify it. So 7, 14, and 16, remember how to test whether or not we have a triangle. We add the 2 smaller sides together, and they have to be bigger than the third side. 7 plus 14 is 21, and so 21 is definitely bigger than 16, so the lengths can form a triangle. Once we know they form a triangle, we then test our converse of the Pythagorean theorem. Well, we say that 16 is the longest side, so that's going to be our C value, and 7 and 14 are going to be A and B. So I'm going to compare 16 squared to 7 squared plus 14 squared. 16 squared is 256, 7 squared is 49, and 14 squared is 196. So I'm going to compare 256 to 245. Well, we can see that 256 is bigger than 245. So because that c squared value was larger than a squared plus b squared, we know the triangle is going to be obtuse. Well, what about for 9, 40, and 41? Again, test to make sure that it makes a triangle first. So 9 plus 40 is bigger than 41, because 49 is greater than 41. So we do have a triangle. Now that we know we have a triangle, we're going to compare the values of c squared and a squared plus b squared. C is always the longest side, so here the largest number is 41, so that's going to be our c value. So we have 41 squared that we're going to compare to 9 squared plus 40 squared. 41 squared is 1,681, 9 squared is 81, and 40 squared is 1,600. Well, then we compare 1681 to 1681, and we notice that they are equal. When c squared is equal to a squared plus b squared, we know we have a right triangle. Okay, I have some guided practice down here. I want you guys to try these. You're given those three values. First, determine whether they make a triangle, and then classify the triangle as acute, right, or obtuse.